Hello everyone, I'm Sushma Vispute here to present my topic data analytics using KNIME tool. So this is agenda of my today's session. So I will cover here an overview of KNIME analytical tool, then installation guide in short, then KNIME data analytics functionalities with demonstration and example with case study. So KNIME stands for here Constants Information Miner. So why this name is given to this tool? Because it is developed by the team of software engineers from the Constance University in the year of 2004. And it's free and open source data analytics and reporting platform. And like your other analytical tools such as Vega, it integrates various components for machine learning operations such as data mining, data analysis, and data manipulation. So here my figure shows the KNIME workflow, which includes the four main components which is required for developing any machine learning model. So here first component is the input component for input data set. Then second is the manipulation component for data pre-processing, then analytics component for data mining and machine learning functionalities, and view component for visualization. So these are the four main steps always be required to design any machine learning model. So here in short, I will cover what different functionalities are available in the KNIME tool that we can use to develop the model. So before that, we'll see the KNIME workbench. So this slide shows here the KNIME workbench, which is like your other programming language editors, right? Is divided into multiple windows. So if you observe here, this is the workflow project window where you can, when you create the project, the details about your project you can see in this window. Then here it is a workflow editor. So here actually KNIME is the tool where we no need to code anything. We can drag and drop the components those are required to develop any machine learning model. So here you can connect all these components, right? Also, you can configure these components and execute this component to see your final output. So this is my workflow editor where you can drag and drop the components from the node repository, right, to build your model. So this is node repository window. This is very, very important window where you can see all the four component that we discussed in the previous slide is available here. The functions, those are required for giving input to the model, for performing different machine learning operations, right, or data analytics, then for visualization of the results, right, and manipulation of this result, or for pre-processing of the data set. All these functionalities are available in the form of nodes in this window. So in the demonstration, I will explain you how you can use these nodes to build your model. And this is one of the feature of the KNIME tool here, that is node description. Whenever you select any component from this node repository, you can find its help or description about this node in the node description window. And these two are the console and outline window. So this is about the workbench. In short, I will cover here what are the installation guide, right? So actually KNIME is the free and open source analytical platform. So just you need to go to the website, and from this website you can download the setup file. The setup files are available for different operating systems such as Windows, Mac, and Linux. Once you have downloaded this setup file, you can install this setup file like your other softwares. So after installing, your setup will be ready to build the model. So these are the different functionalities. Those are available in the node repository window that you can use to build your model. So under analytics, there is a mining menu, and under this mining menu, you can find out all the possible maximum machine learning algorithm that you require to build the model. So here base, in the base you can find the Navy Bayes algorithm. So actually all the supervised learning algorithms are available into the two node format here, that is the machine the for example, here Bayes algorithm. So Bayes algorithm will be available in two nodes, Bayes learner and naive Bayes predictor, right? So learner is used to build the model and predictor is used to predict the or test the result of your testing data set, right? So similarly here clustering algorithms are available. So 4 to 5 clustering algorithms are readily available, and that this tool then rule induction algorithms, neural network algorithm, decision tree algorithm, right? So all these are the data analytics or machine learning functionalities are available under this node repository of the NIME tool, right? So here I want to give you one example. This is the model I have developed on the NIME platform, right, on the NIME tool for the k-means algorithm. So if you observe here, my model is designed using these 5 main components. So first component represents here file reader, which is for giving the input to the model or algorithm. Then second component is my k-means component, which is used to run the k-means algorithm. Then color manager is there. So one of the feature of this k-means algorithm is the color. We can set the different colors as per your choice for the different clusters here that you want to visualize using scatter plot. So scatter plot is one of the visualization technique that is suitable for the clustering technique that we have selected here to display the result of the clustering, k-means clustering here. And another also another technique I have used here, that is interactive table to represent the output of the k-means clustering. So you can see your output in the scatter plot form and also in the interactive table form, which is also shown here. So if you observe, this is the scatter plot for my given model. So this is output of my k-means clustering algorithm. My 3 clusters are formed for the data set. So here a data set uses the iris data sets, right? So red, blue and green, these are the 3 clusters on the scatter plot, and the same clusters are represented here in the table format. If you observe here, because from this scatter plot we don't get idea about the data points in the data set, those are assigned to the specific clusters. But from this interactive table you will get the idea about which row is assigned to which cluster. So in my data input data set, these are the 4 attributes: sepal length, sepal width, petal length and petal width, and my output is here the cluster ID. For time being, we can ignore this class label here because it is not required in the clustering technique. So here my cluster is the column which shows the cluster assigned to these records, right, by the k-means clustering algorithm. So if you observe here, this row number 61 to 677 rows are assigned to the cluster 1, right, which is formed for the one of the category of the iris flower, that is iris is the flower. Versicolor is one of the category of this flower. Then if you observe, row number 78 is assigned to the cluster 0, right, and also you can observe these are the points are assigned into the blue cluster. So these blue lines are here represented in the table formats. And one of the feature of this tool is what also here you can highlight the points in the tables, and that will be visualized in the scatter plot. So these yellow color records are highlighted in this interactive table here. Those are highlighted in the automatically will highlight in the scatter plot also, which is as shown here. So I hope you are clear with this. Another model is here, the example of the decision tree model. So here I have used the file reader. Then partitioning I use because whenever we talk about the unsupervised learning technique or classification techniques, we need testing and training data sets. So my data set is here in the file reader. My file reader will provide data set to the decision tree algorithm. But before that, I have used here partitioning node to divide my data set into the training and testing data sets. So my training data set I have given to the decision tree learner. So my decision tree learner will build the model by using this training data set. Output of this partition is training and testing data set. First partition is training data set. Second partition is the testing data set. So this second output is the testing data set, that is input to the decision tree predictor. So one of the input to the decision tree predictor is my output of the decision tree learner. So here my model will be one of the input, and second is the testing data sets. My decision tree predictor, when we will execute, will give the class label, predicted class label of the testing data set into the interactive table. So here I have used interactive table as a visualization technique. So let us see the demonstration of this on the KNIME tool here. So I have started here my KNIME tool. So it takes time. That's why I have already started here. So this is my KNIME editor where you can build the model. So this is the model that we discuss on this slide. So here now I want to create the new project to build the decision tree model. So you can go to the file and you can say new project. So here my project name is anything name you can give here to the project. Then here, as we discussed, first we require the input file, right? So you can go to here node repository. In the read section, you can go to these all are the different file types available in the KNIME tool. So if your data set is in the CSV file format, you can select here CSV reader. If your data set is in the XLS format, you can select XLS reader. If your data set is in the data type file, then you can select here the file reader. So my data set now is in the data type file. So that's why I have selected here file reader. So here my role of the file reader is to provide input to the model, right? So now I will configure this model. So every node you need to, before going to execute any model, you need to configure the node that you are selecting for developing the model. So here for the in the browse, I will select the data set that I want to provide to the model. So here I'm selecting my data set. So my data set is in the data set folder. So I want to select here the diabetes data set. So my data set file is here, data file, right? So if you observe, you can also find out the description about this data set, of what columns are there. So there are total 9 columns in this data set, and my last column is the class label column. So you can say apply and OK. So my file reader is ready for the execution. If you observe, every node is having this 3 line like your traffic signal. So before configuration, my light will be red. So it indicates configuration is not done yet. Once you have configured your node successfully, this light will become yellow. And after configuration, you can execute this node individually. So if your node is executed successfully, this light will become green. So it indicates what my node is executed successfully. If there is any error, so triangle sign with the yellow color will comes here to show the error. Also, individual node you can execute, or at a time all the nodes you can execute, that both the options are available here. Then second node that I want here is the partitioning, because I want to partition my data into training and testing data sets. So you can also type in the search window partitioning. So here under this manipulation menu, there is a partitioning node. So here you can configure this node. So in the configuration, I need to set the size here. So here I want 80% data into the training data set, right? So, and also these are the options available here to select the data from the whole file. Either you want the data from top position, or you want to apply linear sampling to select the data set, or you want to take this data randomly, or you want to select this data using stratified sampling. So these options are available here. So here I have used the random sampling algorithm. So say, okay, so now LO means my node is configured successfully. Then you can execute this node. If you see, my output of the partitioning node is what? The division of the partition into training and testing set, means 80 and 20% partitioning. So here you can also see these partitions. So my first partition is 80% partition, and second output is the remaining rows, right? So as you define in the, that you can also see here. So my data set contains here total rows selected are given here 614, right? So out of whole data set, 614 rows are selected here. That is 80% of the whole data set in the my first partition. And second partition, you can see here 154 rows, that is 20% records from my whole data set is selected in the testing data set, or you can say second partition. Now I want to give this output of this partitioning to the decision tree learner, right? So decision tree learner is defined under this analytics menu, and here mining, and then in under mining there is a decision tree algorithms. So these are the 2-3 decision algorithms are defined here. So I want to use here basic decision tree algorithm. So I have selected here decision tree learner. So output of the first partition I'm giving as the input to the decision tree learner. So you can configure this node. So here you need to select the class column. So my class last column is the class column, the 9th column that I have selected here. Then either you want a gain ratio or Gini index, that you can select here. Then pruning technique, also you can mention whether it is MDL or no pruning method. And these are the by default parameters I'm taking for the building the decision tree. Then you can say apply and okay, my node is configured here successfully. Then you can execute decision tree here. So once your node is ready, you can also see the decision tree simple view here. So my decision tree is generated here. Then I want to use the decision tree model to predict the class of the testing data set, right? So now I want here decision tree predictor. So I am selecting from here decision tree predictor. The input to the decision tree predictor is output of the decision tree learner and my testing data set. So my testing data set is the second partition of the partitioning node. So again, you want to configure, you can configure. You can change here the label of the prediction column. I'm keeping as it is. The name of my predicted column is what? Prediction column number, right? So here apply, okay. Then you can execute this, and your output of the output of this decision tree classifier you can see in the interactive table. The suitable technique for this is the interactive table. So I'm selecting interactive table from the views. So under views menu, interactive table is defined. So again, you can execute this node and you can see the output of this table. So if you observe, this is my input data set and this is the predicted class for the input data set. So if you observe here, my actual class label is 1, which is in the data set, my original data set, and predicted class is 1, means this row is correctly predicted by the my model. Second is also correctly classified. If you observe here, row number 28 means as per this data set, it is 7th row, which is misclassified. My actual class label is 0, but here my predicted class is 1. So some of the rows are misclassified, and you can measure the accuracy of this model. So it shows that my model has is not having the 100% accuracy, and ideally it is not possible also 100% accuracy. So as you know, we can measure here the accuracy of this model. So also scorer is there that you can select. Scorer, actually there are 3 types of scorer available here in the KNIME tool. First one you can use for the classifiers, right, which will give you output in the form of confusion matrix, precision, recall, and also accuracy and other measures. Numerical scorer is used for the numerical models. For example, linear regression. In the linear regression, my output values are the continuous values, right? So in that case, I will use here numerical scorer. So numerical scorer will give you the R square value, then mean square error value. That is you can obtain with the help of numerical scorer. The entropy scorer is also there to measure the quality of the clusters, right? So here my suitable technique for the classification technique is my scorer, where I want to find out the accuracy of the classifier in terms of the different parameter, precision, recall, right? And also accuracy, right? So here I want to configure, but before going to configuration of this model, I need to give the output of the predictor as the input to this scorer. Then you can configure this node. So here in the configuration, you need to select the column, actual column and the predicted column. So by default, these values are there. I am keeping as it is. So first column and that I want to compare with the second column, that is predicted columns, right? So you know the formula for calculating the accuracy, always the my loss or the accuracy of the model is calculated based on the actual class level and the predicted class level. So that value I am providing as a input to the scorer here in the configuration. So column 8 is my actual class label and prediction column is the column predicted by the model. So say apply and OK. Then you can execute this scorer function and you can see here the output in terms of confusion matrix. So if you observe here, these are the false positive values and false negative values. So definitely my accuracy is not 100% here. So you can also see the accuracy in terms of different parameters here that I want to show you. That statistics you can see in the accuracy statistic column. So here my last column represents here the accuracy with respect to different parameter here. So if you observe here, true positive, true negative, then false positive, false negative, these values are also given. Recall, then precision is given. Sensitivity, my recall is a 76% here. Precision is 82.3%. Sensitivity is 76.7%. Also specificity. Then F measure is 79.4%, accuracy is 73.4%, and so on. So like this, you can see the accuracy of every model. And once you are ready with your model, like this, you can develop the model for your same data set, different models for the same data set, and you can measure the accuracy here in terms of your graphs. So you can compare this accuracy and you can publish your paper research work in the quality journal. So this is about my KNIME tool. I hope all are clear with this. If any doubt, your suggestions or your queries are welcome here. Thank you. Thank you very much.